Welcome again to Math 800 Pre-Algebra. Today we are doing section 6.2 Rates. Our objectives: 1. To write rates as fractions, 2. To find unit rates, and 3. To find the best buy based on cost per unit. A rate is a comparison of measurements with different types of units. This is a key difference. Ratios had the same units. Rates have different units. We use rates and ratios in different places, so it's very important to know when you're dealing with a rate, which is different units, and when you're dealing with a ratio, which is the same units. If you hike 18 miles in 4 hours, this can be expressed as a rate, 18 miles in 4 hours. The in is our division. We can simplify this, divide both top and bottom by 2, and we get 9 miles in 2 hours. This is a rate because it's different units. Notice we keep the units. In a rate, you will often find one of these keywords separating the quantities you are comparing. The keywords are in, for, on, per, and from, depending on the situation. The one most often used will be per. Example: write each rate as a fraction. 5 gallons of chemical for $60. So we have 5 gallons for $60. We can divide both the numerator and denominator by 5, and we get 1 gallon for $12. Make sure in a rate that you include both the units, gallons and dollars. So this simplified to 1 gallon for $12. Example B, $15,000 in wages in 10 weeks. So that's $1,500 divided by 10 weeks. Divide both top and bottom by 10, and you get $150 per week, per 1 week. 2,225 miles on 75 gallons of gas. So 2,225 miles in the numerator, 75 gallons in the denominator. We can divide them both by 25, and we get 89 miles in 3 gallons. Notice of these three rates, this middle one is special because the denominator wound up being 1. So we would say this is $150 per week. This is an example of a unit rate. A unit rate is a rate where the denominator equals 1. It is often helpful to get all your rates to be unit rates to talk about them as far as comparing them, and in general most rates we talk about are written as unit rates with a denominator of 1. For example, if you earn $12.75 for 1 hour of work, you can express that as the unit rate $12.75 per hour, or sometimes instead of writing the word per we use the slash. These two things are the same. It means you earn $12.75 in 1 hour, but we always say it as $12.75 per hour. Example: write 337.5 miles on 13.5 gallons of gas as a unit rate. So we're comparing miles to gallons. We're going to divide both the numerator and the denominator by 13.5 because 13.5 divided by itself will give us that denominator of 1. To do this, we'll have to do long division. Again, move that decimal over and then do long division like normal. And you'll get 25 miles per 1 gallon, which we write as just 25 miles per gallon, or 25 miles / gallon. We read this as 25 miles per gallon. Write 549 miles in 18 hours as a unit rate. We have 549 miles divided by 18 hours. We're simply going to do this long division, 18 on the outside, 549 in the inside. In this case we need a decimal. Whether you have decimals or fractions is determined by the values. If you have a terminating decimal, or if the problem tells you to round, go ahead and use decimals. However, if you have a repeating decimal and it doesn't say anything about rounding, then write your unit rate as an improper fraction. In this case, however, it's a terminating decimal, it's just 0.5, so we'd say that the unit rate is 30.5 miles per hour, or 30.5 miles / hour. I should also note that for these miles per hour, you could also write 30.5 mph. That would be fine. Write $810 in 6 days as a unit rate. So we have $810 over 6 days. Do the long division. In this case, we get a whole number. And so the unit rate is $135 per day, or $135 / day. Again, the slash and the per mean the same thing. Some unit rates are even more useful. These are ones that have to do with the dollar amount to a certain number of items. We call this cost per unit. So cost per unit is a rate that tells how much you pay for one item or one unit. So here are 3 examples. If you pay $3.25 per gallon, or $47 per shirt, or $2.98 per pound. Anytime you're comparing a dollar amount, the amount you spend for one thing, that is a unit rate. Here's an example of how unit rates can be very handy. The local store charges the following prices for pancake syrup. Find the best buy. We have 12 fluid ounces for $1.28, 24 fluid ounces for $1.81, and 36 fluid ounces for $2.73. We have to determine which one is the best buy. To do that, we want to figure out which one is the lowest cost per individual ounce. So, to find a unit rate, the cost per unit, we want to have cost in the top, per, and then the units, in this case ounces, in the denominator. You will always have your cost in the numerator and the number of units, whatever it is, in the denominator. That's because it's a unit cost. It's cost per unit. So cost goes on top. It is sometimes handy to have a little chart when you're comparing several different things. In this example, we're comparing 3 different things. So having this chart can help organize your work. We're starting with our 12-ounce bottle. We know the 12-ounce bottle is $1.28, so we want for our cost per unit, $1.28 per 12 ounces. In this case, when you do the long division, it's a repeating decimal, but when dealing with costs per unit, I would recommend rounding to the nearest thousandth or the nearest 10,000th. In this case, we round to the nearest thousandth. Remember, when you were doing your long division, you would have needed 4 decimals in order to determine if you round up or down. We don't just stop after 3 decimals. You need that 4th one to determine if this should round or not. So the 12-ounce bottle is approximately, and notice how I did not use an equal sign here because it's not equal. It is close to, but not equal, so I use the approximate symbol. It's approximately 0.107 cents per ounce, so a little over a dime per ounce. The 24-ounce container costs $1.81. Again, if we do this long division, we're going to round to the thousandth. We get about 0.075, so a little bit more than 7 cents, and this is per ounce. The 36-ounce container costs $2.73. When we do that long division, we get about 0.076. Notice how close these are. Rounding is really important. You need to have at least one more decimal in order to round. If they round to be the same value, then include the 4th decimal. You shouldn't have any problems that are still the same after 4 decimals. After 4 decimals with rounding, you should have a difference between your cost per unit. So as we can see, the most expensive per ounce is the 12 ounces. And in this case, the cheapest is actually the 24 ounce. So a lot of people assume the bigger sizes are automatically the cheapest. However, companies know that people assume this, and so sometimes the bigger sizes are actually a little more expensive so that people are wasting money. I often do this in the grocery store if I'm trying to decide sizes. Granted, I whip out my cell phone and use the calculator on my cell phone to do the long division, but this is a very useful thing and something that can save you a lot of money. So the best container, the best buy based on the per ounce is the 24 ounces. Suppose you are looking at these choices for extra strength pain reliever. Both brands have the same amount of pain reliever in each tablet. Brand X is $2.29 for 50 tablets, and brand Y is $10.75 for 200 tablets. However, you have a 40 cents coupon for brand X and a 75% coupon for brand Y. Which is the better buy? First, we're going to subtract that coupon from our prices and then find the cost per unit. So brand X, once we have our 40 cents coupon, will cost us $1.89. So the cost per unit will be $1.89 divided by the 50 tablets in one container. And when we do our long division, again rounded to the thousandth, we get 0.038 per tablet. So each tablet will cost a little more than 3 cents. Brand Y costs $10.75, but we have our 75 cents coupon, so it's only $10. So then we do our $10 divided by the 200 tablet. In this case, notice we didn't have to do any rounding. It comes out to exactly 5 cents per tablet. It's pretty clear that brand X is significantly cheaper because it's a little more than 3 cents per tablet. So brand X has the lower overall cost because it's the lower cost per tablet. It is the best buy. That concludes section 6.2. Your next steps are to complete the worksheet for section 6.2, then check the key for worksheet for section 6.2, and then do the online homework through My Math Lab.